All right. Hello and welcome to Mr. Slaney's classic perfect answer to is some function f of x continuous at x equals 0. Notice, x equals 0 is on this like boundary point here. So this is a classic test question, classic situation that might come up on the AP test. Not as like a full question by itself. I still want us to know how to answer this and tie everything together though. Is f of x continuous at x equals 0? Well, there's some big conditions that need to be met. You all probably know off the top of your head. To be continuous at x equals 0, the biggest thing is that the limit as x approaches 0 of f of x must be equal to f of 0. That's the classic definition. Both of these need to exist as well, right? 'Cause that way we can't have, well, the limit does not exist. And the value of the function does not exist, therefore discontinuity. So even though it sounds silly, I just want it to be a little, extra about that. So how do we take this and get here? In the math, right now my AP Calc students, the 0.3s, are all very good at doing the math around this. But getting the writing the answer is something that is also worth noting. Let's take a look. So most of them would copy down these values. All right, the limit as x approaches 0 from the left of f of x, the limit as x approaches 0 from the right of f of x, the limit as x approaches 0 of f of x, and f of 0. Well, f of 0 is wicked easy, right? Because we can just, let me bring this back. Oh, well, when x is 0, f of x is 5. Boom. The limit as x approaches 0 from the left, I need to use this leftmost part of the function. So this equals the limit as x approaches 0 of cosine of x plus 4. Please note, I don't really need this any notation around that 0 to say right or left, because, hey, on the left of f of 0, f of x is cosine of x plus 4. Let's plug in 0. We get cosine of 0 plus 4. I had an awesome pre-calc teacher, so I know that cosine of 0 is 1. 1 plus 4 is 5. All right? And right away, I know that these, we're looking equal, we're looking good. The limit as x approaches 0 on the right, so now I need to use this part of the function. It is the limit as x approaches 0 of the square root of 25 minus x squared. Any issue with throwing in 0 there? I don't think so. This just becomes the square root of 25, which is 5. And oh snap, these are the same. Therefore, the unsided limit of f of x is also 5. So right away, I know that this is going to work out. Let's look at how to write the actual answer. So I examined on the left of 0, on the right of 0, and then that allowed me to write this. Without doing these, that doesn't work. f0 is 5. So let's explicitly answer the question. Yes, f of x is continuous at x equals 0 because, right? So notice I'm sort of doing that that like flipped question deal that they teach you in like 5th grade. Restate the question, explicitly so you can answer it, because the limit as x approaches 0 of f of x equals f of 0. I could state that they're both equal to 5, but ultimately, whatever. Let's take a look at where this doesn't work out quite so nicely. Let's do f of x equals, let's make my boundary point something more exciting. Let's make it 1 greater than or equal to 1. Let's do x squared and 2x plus 3. And let's write the question, because math without a question is just sort of babbling nonsense. is f of x continuous at x equals 1? Let me set up my four little things here. All right, the limit as x approaches on the left of f of x, the limit as x approaches 1 on the right of f of x, and the limit as x approaches 1 of f of x and f of 1. Well, on the left, we are x squared, so this is going to be the limit as x approaches 1 of x squared. That's just 1. And this is the limit as x approaches 1. We're on the right. This is the plus sign. On the right, we are 2x plus 3. 2x plus 3, plug in 1, we get 2 plus 3 is 5. Uh-oh, spaghetti-o. And consequently, because these are different, this does not exist. I'm not even going to worry about this because I have all the information I need. Let's write my solution. F of x. Notice that even though I'm starting the sentence with f of x is lowercase because it's the name of a function. So f of x is not continuous at x equals 1 because the limit as x approaches 1 of f of x does not exist. All right. I hope that you found this helpful. A very similar question is going to be on your test. I don't know if, it could be continuous, it could be not continuous. It could be because the output is different from the limit. But ultimately, if your limit does not exist, or if your function does not exist, or if these two numbers happen to be different, right? If this number were a 6, then my first f of x would not have been continuous, right? And then I would have had to write f of x not continuous at x equals 0 because these two things are not equal. But there's a very small scope of what this will look like on your test on, sometime in June. Bye-bye.